This question scares me right away because I can see that it's about percentages, right? 40%, 20%. And through experience, I know that percentages on the SAT are a trap because the SAT a lot of times knows that we think about percentages in an incorrect way. And so they deliberately ask questions to kind of, catch us in those traps. And so we need to make sure we have a system for handling percentages questions. So there's lots of formulas out there in the world for dealing with percentages. I don't think any of them are very good. I think that they require too much thought or they vary too much based on the situation. And so I have come up with my own formula that I call the open formula. And this helps me deal with the specific way the SAT asks percentage questions. So I'll talk about what this means, but I really recommend that you memorize it. If you have my SAT study guide for math, you will see plenty of stuff about this formula. It comes up again and again and again. There's a lesson on it, and it comes up in all the questions that are about percentages. I stick to it. So I'm going to stick to it here. So first of all, what do they want? Okay, they want me to look at the Glenview Street property. That's right here. So I'm just going to copy this information down. We have, it's $140,000 for the purchase price. Is that what I care about? Purchased it. Yeah, they got it. Okay. Price of the original price. Yeah, okay. So I don't care about the rental price. I just care about this. Okay. So let's zoom in here. So the key to the open formula is knowing that there's a difference between the O, which stands for the original amount, and the N, which stands for the new amount. That doesn't need parentheses. The new amount, right? Because when we do something with percentages, there's an original value that we're taking a percentage of, and then there's a new value. And along the way, we, in this case, are getting a percent decrease, right? Sometimes we say, what is 40% of 250? But that's not what we're saying here. We are saying they got a discount of 40%. So we need to account for that. And so the P in open stands for percentages, right? So in this case, because it's a percent decrease, I'm going to use 1 minus P in that spot. So let me just review the formula. O, the original, times the percentage. E stands for equals the new value. Okay? Now in this case, we've got two percentages, and there is a little bit of a shortcut we can use here. I'm not going to do it right now. I'm going to just go through methodically just to make my point. But here's kind of how we would deal with this. So first, we have to understand what this 140,000 is. That is the new price that's being paid. How do I know that? Well, because they're asking for the original price. So I don't know the original value of this house. I know that it ends at 140,000. And I can take these discounts one at a time. So let's just go one piece at a time here. Townsend Realty purchased the Glenview Street property and received a 40% discount off the original price, along with an additional 20% off the discounted price of purchasing the property in cash. So we can go in either order here. If you want, we can work totally backwards, so that way it kind of fits with us ending with the 140,000. But that's going to mean that the original is what we're solving for. It's not this original. It's kind of a middle original. But it's going to be 1 minus 0.20, right? That's this, equals the 140,000. So we can just simplify. Let's just call this, keep calling it the original. 1 minus 0.20 is 0.80. And what's going to end up happening, which is kind of weird, is in order to solve for this missing piece, we're going to end up dividing by the percentage. And that's why the SAT sometimes can kind of slip this by us and make us make mistakes, because we're not used to thinking about percentages in terms of division. We're used to thinking about percentages in terms of multiplication. And so look what happens here. We get something that's an answer, but it's not the final answer. But we get a number that's bigger than what we kind of started with here, because we're working backwards and we're reversing the discount. So it's weird, but this is how percentages need to work, is we need to make sure whether we know whether we're multiplying or dividing. Okay, because if we do the opposite, we're going to get a completely different answer, and I guarantee you it's going to be one of the choices. We have to be really careful here. But this is not the final answer, because we still have another discount we need to apply. So I called this the original for the sake of the formula. This is kind of like the middle value, right? This is just reversing one of the discounts, but we can reverse the other one the same way. We now take this is our new value, and we need to reverse the discount to find the original, and that is going to mean we reverse a 40% discount, which looks like this. We take away the 40%. That means what's going to happen is we're multiplying by 0.6. So there's a lot of things going on here that are kind of weird. And notice, even though it's 0.4 is the discount, 40%, the number that we actually end up working with is 0.6, 60%. And we're still going to do the same thing, though. We're still going to divide. And 175,000 divided by 0.6 is, in this case, the final original value is 290 something, 91. It says 666 in my calculator, but that's clearly choice B because that's the closest one. So it's an approximation, but it's good enough. There's only one choice it could be. Okay. So hopefully that was not too confusing. Percentages are confusing though, so if you are confused, don't feel bad. It just takes some getting used to. So I'm going to back it up a little bit and show you how we could have proved that answer using like something like guess and check if we really wanted to. We could have done like a little bit of a shortcut. So if we wanted to guess and check, I would have started with choice B anyway, right? If I was guessing and checking, I would have said, well, let's start with something in the middle. That way I can go up or down depending on whether I'm right or wrong. So I would have assumed that the original price of the house was $291,700. So that's my original. Now again, with percentages, if we're receiving a discount, the number that we work with is going to look different than the discount. So I'm still, in my formula, going to put 1 minus, it was 40% and 20%. 1 minus 0.4, and because percentages don't matter, the order does not matter, I'm going to do both percentages at once. This is the shortcut. We could have done both at once because it's multiplication, right? So 3 times 4 is the same as 4 times 3. So order does not matter with multiplication, so we can do everything at once. But notice it still kind of follows that open formula here. It's the original now gets multiplied because it's the thing that we're taking the discount from. But when we do the math, we're going to take our 291,700 and notice those numbers change, right? The 40% discount becomes 60%. The 20% discount becomes 80%. And that's because, another thing that's hard about percentages is the way that we talk about percentages is very different from the way that we mathematically work with percentages. So if I go to a store and I have a 20% off coupon, right? 20% off. What we say is I have a 20% off coupon. But mathematically what we mean is that we have an 80% on coupon, okay? 20% off is the same mathematically as 80% on. For whatever reason, we talk about the 20% off. But what we really mean is that we're paying 80% of the price. That's what we should say, but we don't. And so that's what we have to keep in mind when we're dealing with discounts and percent decreases in math and on the SAT, because what we say is not going to match up with what we put in our calculators. But right now, we could just put all this in the calculator. So 291,700 times 0.6 times 0.8 is going to get me 140,016. So it's not exactly what we started with, but again, it was an approximation, so we're pretty darn close. And that would have proven to me, if I had worked backwards and guessed and checked, that my answer, choice B, was correct. It's a lot. It's a lot. But just the key piece here is know going into percentage questions that there are lots of opportunities for mistakes. That worry is a good thing. It means it's going to slow you down, make you show your work, make you use the formula so that you are less likely to make the mistake. That's the real point of this special open formula, is it's meant to just slow you down and make you think about the right things, knowing what the SAT is trying to get by you. So try to incorporate it into your strategy and into your process, and I think you'll save yourself some points on these kinds of questions.